So this was not last night's. It was the nights before. Really, really quick. 16, you said?
Yeah.
This is the one that was due yesterday, not today's. So number 16, we needed to get all of these different angles, I guess you'd say. I guess the big thing is you have to start with your number and see how it helps you and how it correlates to another thing. And so if I take this number and I look at this one that's directly across from it, these are corresponding angles. This one and this one are corresponding angles. So you just have to put 68 equals this is equal to this. And then once you get this value, you can kind of use alternate interior to get to this one. Or you can say, well, this plus 90 plus this equals 180.
So, okay.
Right? So
Yeah.
this plus this must equal 90. And then you can use alternate interior to get that as well.
Shoot, okay.
And in fact, since this is 90, this one also has to be 90. So it's those little tricks.
I think I forgot about
Life.
alternate interior, yeah.
Oh, okay.
And corresponding altogether. I was trying to do it just using vertical angles. Okay,
Don't.
That's why I was getting.
Yep. I always look for alternate interior. I always look for alternate interior first.
Yeah.
Then I'll get corresponding. But I always put my finger on the number that they give me and see what's the first thing it can help me with.
Mm-hmm.
And I'm just like, well, vertical's not going to work. There's nothing over here. It's not interior, so I have to go corresponding works. All right, so I just go through that checklist with my finger on that number.
So, okay, hold on. So then what's alternate interior in this one?
Well, you don't even have to use alternate interior if you don't want to.
Just
Because I would just do this as corresponding.
then do that equals 180.
Yeah, or 90, because this part's
Oh.
90, right? So just this little section is equal to 90.
Yeah.
And I'm also going to know, because this is 90 and these are parallel, this one also must be 90, so that must be 30 degrees.
Alright, I'll try with working.
Yeah, awesome. All right, other questions from tonight's homework, Sabrina?
For number 24 and number 24, and also what I also confused about is in the last subject.
Okay, number 24.
Yeah.
We didn't have to do 30. We didn't have to do 21. That's what was good.
Yeah.
Oh, we did 24.
Okay, number 24 I got up there. What about 24?
Oh, I didn't get how the answer. I got the answer, and I got the answer. I didn't get how I got the answer.
Okay, so let's just go through what they did in the homework. So 24 says, given that BE bisects DBA, angle 3 and angle 1 are congruent. So BE bisects DBA. So let's go ahead and say, okay, BE bisects DBA. So that means just right off the bat, I know that this is equal to that. And it also says that angle 1 is equal to angle 3. I'm on the right one, right? 24?
Yeah.
So 3 is congruent to 1. It's kind of hard to draw that. Can you already see that 1 is congruent to 3, which means it's congruent to 2? Because it's hard to draw it otherwise, right? It's hard for me to say 1 is congruent to 3 without saying 1 is congruent to 2. So in fact, that is your entire proof. Your entire goal of this proof is to prove they're parallel, right? Correct? And the only way you can prove things are parallel is if corresponding angles are congruent, alternate interior angles are congruent, or same side are supplementary. So your only goal is to say 1 is congruent to 2, and you are done. Well, they told me that BE bisects to 3. So let me go ahead and take a picture of what they have in the answer guide. So they did exactly what I would have done. They said it bisects, they unpacked it and said that 2 was equal to 3. Then they gave the given that 1 was equal to 3, which was the other given. And then they went ahead and said that 2 was congruent to 1, just using the transitive or substitution property. And as soon as you say that 2 is equal to 1, they're alternate interior angles, so they have to be parallel. Did you have a specific question from the answer, I guess?
No, I guess I just kind of didn't really get. And then also another thing is usually in the last answer it was like corresponding transitive angles are like I didn't really get the so like for number 17 last answer, number 22 last answer.
17, let me look at 17. That is just the theorem stuff we learned that day. All they are saying is like this one is if alternate interior angles are congruent, they're parallel. That's all they're saying.
Oh, but do we have to put down that like?
You don't have to put down the whole thing.
So what can I put as like a replacement?
You could put alternate interior angles are congruent, so it's parallel.
Oh, okay.
Or you can put the alternate interior angle converse, because it goes the opposite direction. Where alternate interiors come from the fact that if they're parallel, they're congruent. If they're congruent, they're also parallel. If you say anything with alternate interior angles, I know what you mean. Okay, other questions? Yeah.
I don't understand how to do number 20.
20? So number 20 was... So 20 was just asking for stuff that could be true. So it says, given that angle 1 is congruent to angle 2. And it also says that angle 4 is congruent to angle, or 5 is congruent to angle 4. And we know that 2 and 5 are congruent, right, because they're vertical angles. So what they want you to be able to see is that 1 and 4 are congruent. That was the whole goal, so you can see those are, which means that these are parallel, right? And then we could say other stuff. We can say 3 is congruent to 6. We could say 1 plus 3 equals 180. But the big thing is that you could see that these two, 1 and 4, were congruent, so they're parallel.
Okay.
That was the big guy in that one. Other questions? Yeah.
Could I ask a question from 2 nights ago?
Can we not? Or otherwise we're going to run out of time. You can come see me after school or something. All right. Yeah.
This is just a kind of a quick thing about
Yep.
what I saw in the answer key.
Mhm.
So, I put down like so on number 20, like it was like kind of the same answer, but except I wrote it down instead of like writing the. So it's like that. It was like that was like what the answer was, but I wrote it out instead of putting the.
2 columns?
Yeah.
Or the symbols?
Yeah.
So you didn't use symbols?
No, I wrote it out.
Okay, that's fine. You don't have to use symbols. Symbols just going to speed things up, yeah.
I have a question about 22. I did it a different way, but I think it works. But I'm not sure.
Okay. 22. Yeah.
So, for the first one, I did angle 1 plus angle 2 equals 180, which was given.
Mm-hmm.
Then the measure angle 2 plus measure angle 3 equals 180, and that would be angle addition postulate. And then the third one I did was measure angle 2 plus measure angle 3 are supplementary definition of supplementary angles. Then the fourth I used was measure angle 2 plus measure angle 2 equals measure angle 1 plus measure angle 2 for transitive.
Mm-hmm.
And then 5 I did measure angle 3 equals measure angle 1 substitution or subtraction. And then 6 was L is parallel to N. And I used theorem 2.5.
Yeah, that's good. That's good. You just used a different kind of theorem kind of thing. No, yours is good. Other questions real quick? This is going to be the last one, very last one. All right, no, then we will continue. Remember, if you still have questions, please come see me. I'm here before and after school. We just can't cover every single question possible. Also, you can email me, and I will try to answer as best I can. Okay, we're just going to go through some theorems that we're not going to use very much in these first two, particularly this first one. And the second one, I guess. We're not going to use them too much. You probably won't even use them in a proof. You can, but I can't recall ever needing them in a proof in this class because I just don't think they're the most necessary. Okay, so theorem 3.8 says through a point outside a line, there's exactly one line parallel to the given line. I think that's just kind of, it makes sense, right? If I make a point right here, there's only one line I can draw through this. Right? There's only one way I can draw this line, that it is parallel. There's only one way I can draw it, that they're not going to intersect. The only way I could draw it without it being intersecting is I could skew it, but then they'd be skew lines. All right, so I read this one, I'm just like, yeah, of course. Why do I need a theorem for this? I mean, it just makes sense. One point, there's one line going through it. Any major questions on that? No? Okay, I didn't blow anyone's mind? All right, through a point outside a line, there is exactly one line that's perpendicular to the given line. So once again, I have a line and I put a point. I can't think of another way. Like if I draw it like that, that's not perpendicular. If I draw it like that, that's not perpendicular. There's only one possible way. I kind of have a snap grid on, so I can't put it perfect. There's only one possible place I can put it that makes it a perpendicular thing. We do have to cover it because sometimes they'll ask like a question in the homework and it'll be like, just go through it. All right, but those are two I mean, they're theorems. It's good to know, but for me, they're kind of like, duh. I mean, I got it, man. I only can draw one line to that point. Nailed it. Good job. Awesome. That's math. All right, that leads us to a theorem that is good to know. It's good to know. It's not super difficult to prove, and we'll go through it. But Theorem 310 says two lines parallel to a third line are parallel to each other. So if line A is parallel to line 2 is parallel to line 3 must be parallel to 1. I just blew all your minds, didn't I? You're just like, how is that possible? Right? That's the face I was looking for. Okay, let's go ahead and prove it. I mean, it seems obvious enough. Let's go ahead and prove it, just so we can have practice going through these. All right, two lines are parallel to third. So this one says, it's kind of tiny. So what I might do, I should probably retype these, but I'm just going to actually write these in, that K is parallel to L, and K is parallel to N, just so I don't mess anything up. And I'm trying to prove that L is parallel to N. All right, so our very first thing, let's go ahead and state what's given to us. We should always have that one right. K is parallel to L, and K is parallel to N. And my reason is, hey, guess what? That was given to me. Now I'm thinking right now, I know I need to prove that two lines are parallel, so I'm thinking about the different ways I can prove two lines are parallel. We can either say corresponding angles are congruent, we can say alternate interior angles are congruent, or we can say same side are supplementary. Well, I gave you a nice list of numbered correspond. Yeah.
Oh, I was going to say corresponding.
Oh, I blew the punchline for you, didn't I? I'm sorry. Yeah, we're going to use corresponding angles. So our whole goal is I'm trying to prove that L is parallel to N. So I want to somehow prove that 2 is congruent to 3. And we're done. As soon as I can say 2 is congruent to 3, we are done. We say because of corresponding angle converse, we are done, they're parallel. So let's go ahead and show that 2 is congruent to 3. So what I'm going to do is I'm going to unpack what these two statements mean for the corresponding angles of our given information. So my second step is I'm looking at, well, K is parallel to L. Well, if K is parallel to L, that means angle 1 and angle 2 are congruent, correct? Does that make sense? So I'm going to say angle 1 is congruent to angle 2. I'm going to piggyback on this one. This could be done in another step, but I'm going to piggyback on the fact that, how do I know these two things are congruent? Yeah, Lydia?
Because K and L are congruent. Or parallel.
Parallel. What kind of angles are they? Amber already blew the punchline. Yeah.
Because they are acute angles.
Not acute. They are corresponding angles is what I'm looking for.
Oh.
Because they're corresponding and these are parallel, they have to be congruent. Right?
Yeah.
Acute just means they're smaller than 90.
Yeah.
I don't think every angle is smaller than 90. Maybe it is. Maybe. I don't know. But my next thing is, so K is parallel to N, right? So I'm going to say that 1 is congruent to 3. That's the same corresponding angle property, right? So as long as I'm using the exact same property, I can piggyback steps. So you could have, in 2 steps, listed angle 1 is congruent to angle 2. And you could have did a whole new step saying that angle 1 is congruent to angle 3. So that could be a whole new step, but since it's the exact same reason, I'm just going to piggyback and just say they're both corresponding angles.
Wait, is that a theorem? Was that a theorem?
Oh, yeah, it's a theorem. No, it's postulate 10.
Oh, yeah.
That's why I don't get overly concerned about what they're named, because it's just easier just to say, I know what you're talking about, you know what I'm talking about. All right, but our end goal is to prove that these two things are parallel, L and N. So I want to prove that 2 is equal to 3. Is there any way to say that 2 is equal to 3? Do we know that for a fact right now?
No.
Do I know 2 is equal to 3 right now?
Yeah.
Yeah, so I'm going to go ahead and say that. I'm going to say angle 2 is congruent to angle 3. Oh boy, I have to do a reason. I don't know the reason. Can anyone help me with the reason? Yeah, great. Substitution. I would use substitution, not transitive. Transitive would have been if 1 went to 2 and 2 went to 3, then 1 goes to 3. There's no train here. It is 1 goes to 2 and 1 go. Kind of picture like a train. Do you ever hook up 2 cars to the same engine? Can you picture an engine? And then I hook a train up and a train up over here. No. So this doesn't work as transitive, so it would just be substitution. Don't use transitive on this one. We are done. We are done because now I can say L is parallel to N. And what I'm going to list for my reason, we could go through the sheets and figure out which theorem it is. I'm just going to say, well, I use corresponding angles, so I'm just going to say the corresponding angle, and I'm going to say it's the converse. That's supposed to be an R. I'm just going to say it's the converse.
We'll get the theorem sheet for the test, though.
Yes, you will. You can definitely put your numbers down, or you can just tell me what it is. Sometimes it's nice where you don't have to, like, especially when you're like, it's like you're short on time, not having to dig through all the ones, come up with the perfect number, just be like, corresponding angles, Mr. Baby knows what I'm talking about. All right, I'll know what you're talking about, as long as you don't make one up, where you're like corresponding angles of same side angles, acute style. Right? Don't just give me flippity jam. It's got to be something you know was a theorem or a postulate.
We did the converse of the opposite, right?
Converse is the opposite direction. So normally when you say converse angles, you're like, hey, if 2 parallel lines corresponding angles are congruent, the converse would be if they're congruent, then they're parallel. All right, that's 310. Ways to prove 2 lines are parallel, you can look through all of it. What I'm really looking for is I'm looking for corresponding angles, alternate interior angles, and I'm looking for same side interior. I'm trying to prove one of those 3. All right, this goes into if they're both perpendicular and all kind of stuff. But if they're both perpendicular, every angle is 90. So if you looked at same side or alternate interior, you would still look for them being the same. They just both would be 90. All right, so look for those 3 angles to either prove that things are parallel, or if things are parallel, you're going to use those facts to say they're congruent. All right, we show they're congruent to show they're parallel. If they're parallel, we can show they are congruent. All right, this is more for you. It's not really part of the lesson. I'll put a picture of what I put up in these boxes. But during work time, if you have time, it might be a good idea just to plug in the numbers that correspond to the right ones. Because then if you're someone that really likes looking at the numbers, it's just nice to have one place that has them all that just deal with corresponding same side. So I'll put my picture up during work time, but I don't want to go through it all right now. But I'll put my picture of what I put in each of those. I'm going to get right to our exercises because hopefully you have time to work. State which segments, if any, are parallel. State the postulate or theorem that justifies your answer. Once again, I'm looking at either same side interior, alternate interior, or corresponding angles. Do I have any same side interiors? I'm just going through my checklist. Do I have any alternate interior angles? No? Evan, what do you think?
Corresponding?
They're corresponding. So are they parallel?
Yeah.
But this is, what do we do? This is 50 and this is 52. How do I know that they're parallel?
But isn't OX
Yeah, how do you know that? But how did you do that?
52, 28
Oh,
equals 50 plus 30.
awesome. Great job. That's perfect. That isn't that easy to see. Was it that easy to see?
I didn't know you wanted me to say it like that. But you're asking for like a.
Who missed it?
I definitely,
Who immediately said there's nothing parallel because 50 and 52, well 30 and 28, those aren't even anything.
I know.
But what Ethan saw was he said, well, let's look at Evan. Yeah, nice job, Ethan. I had an Ethan last year, and for some reason, you just remind me of him. All right, so we go all the way across here.
Better been nice.
What was that?
Been nice.
That'd been nice.
He should have been nice, or he should be nice. Right?
Yeah, he was.
Okay, good.
Yeah. No, he volunteered a lot. So if you notice, 50 plus 30 equals 80 degrees. And 52 plus 28 equals 80 degrees. So they are, in fact, they're corresponding angles that are congruent. So that we have two parallel lines. And Evan, or Ethan, however you want to say it, I'm just kidding, is parallel to IZ. What was that? That time was on purpose. You okay? All right. Why are you confused? What confused you?
Oh, that makes sense.
Oh, okay. Then now you're making me confused. Where did I put my stuff? Anywho. So those must be, and now we used the corresponding angles. Or postulate 10, I guess, if you want to put that down. Or let's put corresponding angle, I guess converse. Yes. Robin.
Oh, is it number 3?
Oh, you're already on number 3? Okay. Maybe. All right, number 3.
Oh.
Is anything parallel?
I 40 like the 46 and the other 46 are same side interior,
Mm-hmm.
and then aren't A and T?
What do same side interiors have to add up to, though?
Wait.
Yes.
Wait, I'm confused. Like, in number 2, wouldn't there be another thing? Wouldn't there be another segment that would be parallel?
Could be.
OW and IY.
OW and IY. Why would those be? Because if I look at, hang on, a lot of hands up. I'm just going to answer this question. So you have OW and IY being parallel?
Yeah.
But the thing is, their corresponding angles would be 52 and 50. Are those? Remember that our corresponding angles have to be equal. Are you just saying okay because you?
No, I get it.
Okay, good. Evan?
Well, according to theorem 3.6,
Nice.
Wow.
Wow.
lines are cut by transversal, and same side interior angles are supplementary, and the angles are parallel. So 46 and 44 equals 90. So can't you add 90 and 90 together equals 180?
So what two lines are you saying are parallel?
LA and TS.
I would agree with that. I would say that's at least one of them. I love that. LA is parallel to TS. Don't erase if you have something else. And what number was that one? I always forget. 3.6. So that'd be theorem 3.6. Amber, do you have another one?
According to my brain, T and AS will be parallel as well.
I'll put that down. So you're telling me, I'm not saying it's correct, so don't copy it down unless LT and
Have faith in me.
and AS?
Yeah.
Why?
Because they're both equal. Is it the 90 degrees? Does that have something to do with it? Right answer.
Oh, yeah, that makes sense.
Good answer.
If they were, like, if that one was a little bit that way or the other one was that way, they wouldn't be parallel.
Hang on one thing though. I agree,
Yeah.
if we knew more facts about squares and stuff, I would 100% agree. However, do we know that this and this equal 90 degrees?
No.
Do we know without any kind of assumption on our part, do we know for a fact that this is 90 degrees?
Oh,
Don't we though? Because
Yeah, isn't there a postulate that says that one?
There's a postulate if they're parallel and one is 90 degrees, then the other one is. That's if they're parallel. So you went off the assumption. No, don't get it. It turns out you're correct, but we can't put that down because we don't know why it's correct. Yeah.
Wait, for T, like that, like under that 46, wouldn't that be 46? Like right there.
Yeah, because these would be parallel, right? Which would mean if this is 46, that would have to be 46 as well. So in fact, it wouldn't be. And in fact, this is a very messed up drawing. It doesn't actually make sense. Because in the real world, if this was 90 and this was 90, all of them would have to be 90.
Yeah.
But so because the drawing is purposely messed up, we can't assume
So it's the draw.
it's the drawing's fault. So this is not correct.
With geometry.
Yeah.
L, T, and, or wait, was that just what she asked?
Yes.
Yeah, it's alright.
Yep, that's the only one that's. But do you understand? You just have to get what was given, and you have to have a theorem that backs up what you said. And you were just like, because of the drawing, I know this is 90, and we can't say because of the drawing it's 90.
I promise it wasn't
Yeah.
no academic sound in my head.
LA,
Not parallel, just.
they'd be perpendicular. Yeah. Okay, so that's the only one on that one. Okay, yeah.
For LTA, that 46, I'm confused why AST, or no, not no, why LAT, like where this says the 44, like why would that be 44? Like, cause like if you go like to where the T is, like it should be 46 because of alternate interior angles.
Well, remember, we only know something if something's parallel. So we found out that this is parallel to this, right? Since those are parallel, this has to be 46. We don't know that these are parallel, so these aren't technically alternate. I mean, they're alternate interior angles, but we don't know anything about them unless these two are parallel.
Oh, it has to be parallel.
They have to be parallel to be able to say alternate interior angles are congruent. That's one of our prerequisites. It's kind of like if you're parallel, you're congruent. Just like if you're congruent, then you are parallel, but parallel is the key part in both those statements. Does that make sense?
Yeah, this has to be parallel in order for it to be alternate.
Yes. In order for alternate interiors to be congruent. Evan?
And do 4.
Let someone else do 4. Lydia.
Okay, so GA and EM are parallel because.
I'm going to write it down.
Okay.
Just so I have it in mind and I don't have to keep asking you a million times. So GA and...
EM.
Okay.
I was like, oh,
Okay. Are parallel because?
because of alternate interior angles.
Alternate interior angles. So are you saying that 48 is congruent to 48?
Yes.
Which would make that parallel to that?
Yes.
Is that what you're saying?
Yes.
So you're using the fact that you have alternate interior angles are congruent to be parallel.
Yes.
You're really thinking that's true.
Yes.
Yes, you're right. You're absolutely right. She is absolutely right. It's alternate interior angle converse. Yeah.
Doesn't that mean that? Sorry, I can't say G. G.
Ga.
Yeah. No. GE is parallel to AM. I can't say
Because.
because of the,
No, not the same reason.
What?
Because
Why?
because look at the angle that 48 forms.
Oh no.
Look at the angle at the bottom 48 forms.
Oh no.
Do either one of those create AM or GE? Your angles have to form the lines in the transversal.
God.
All right, remember when we came up with what's the transversal and what are our two lines?
Oh, dang
If you draw this and draw that, you know what your transversal is and your parallel lines. It's the easiest way is to highlight those in. Yes?
So would the shapes in 3 and 4 technically be trapezoids and not squares then?
They would be very error-ridden drawings because this is 90 degrees, this is 90 degrees, which in real life would force this to be 90 degrees and this to be 90 degrees. But through the magic of just putting numbers on a sheet of paper, they do not. So in fact, they're no shape. You could not build this shape. It would be one of those endless stairs or something. All right, so yes and no to your question. Does that satisfy you with a very murky answer? But if this is 90 and this is 90, technically it would have to all be 90. But this doesn't have to be a realistic shape.
No, if it were parallelogram, wouldn't they just like wouldn't L just have to be supplementary to T? Like wouldn't it just be like L plus T equals 180?
I'm just saying how it's drawn and stuff is kind of. But no, you're good. You're good. I think you got what you mean. Yeah, I got what you mean. Yeah, you're good.
Are there going to be like normal shapes on the test? Or are they going to be moving like these ones?
These are normal. Hey,
Not normal.
hey, don't worry. Don't worry about classifying them as squares, rectangles, or anything. Just take the numbers they give you, draw a picture just like this, and don't assume anything. Don't assume because it looks like it's a right angle that it is going to be a right angle. Okay? Yes. No. Just wait a second. Okay. So let's go ahead and look at this. In each exercise, some information is given. Use the information to name the segment that must be parallel. If there is no segment, say no. Once again, I know you have the answer, but I'm going to do one with you. The easiest way to do these is highlight the angle. All right? So this is angle 1. That's angle 1. And you could do this in your head. This is angle 8. So that means these are the lines I'm looking at, right? And you might have to do this in the head because you just don't have so many of them, because you have to do a bunch of them on there. And this would be my transversal. I'm just doing this in my head. I'm showing you what I do in my head. So 1 and 8 are alternate interior angles, correct?
Yes.
So what lines need to be parallel? Hannah?
PL and AR.
PL.
Could you also do PA and R?
No, that's what I answered that one. It doesn't work. Because it's like
Because
which way the angles open up.
Which one did you say, Evan?
PA and LR.
So that's what he has on the board.
Well, I have PL and
Oh.
AR. We can't go the other direction.
Wait, that's the next one, isn't it?
Oh, I did measure 1 and 8.
PA and LR is the next one, right?
Oh, is that what you're saying?
Yeah.
Is it-
Well,
No, I'm sorry. I'm still about 5.
No, it has to be PL and AR. Those are the ones that can be parallel based upon that fact.
Wait, but according to theorem 3.5.
no, it doesn't work because it's like the way that
Evan, look how I drew it.
Yeah.
Right? The angle has to form the transversal and the line,
Yeah.
and this one forms this one.
Can't you do it like that way? That way?
For anyone that knows the answer to this, you can continue on. You're going to be doing the rest of these. I just want to address Evan's question. So you're thinking that,
So it goes from PA,
what would you say, PA?
Yep.
You're saying that's parallel to
LR.
LR because of angle.
1 and angle 8 are alternate interior.
Angle 1 doesn't even touch this line. The end of angle 1?
You have to have it inside of it. Like that's
Wait, what?
You just pick the line.
That does.
No, it doesn't.
Because it doesn't have it. Doesn't it?
So if I'm looking at this,
Yeah.
if I'm looking at this, and I go ahead and highlight the transversal you're talking about, that means the only thing in the world that exists are our 2 parallel lines and our transversal.
Oh.
1 stops here and it's using a line that isn't even highlighted.
Oh, so in order for it to be PA is parallel to LR, it would have to be angle 2 is equal to angle 7. Okay.
You got it. All right, let's do the rest of them. You're in charge of doing the rest of them. while you're working on the rest of them, I'm going to go ahead and show you the kind of the picture, kind of what I want you to kind of have on that section that I had.
They just don't look the right side. Alright, I just looked at it.
Then you're assuming things. I don't
Well,
Robin, you can go to the bathroom now if you want to. But we can't do that every day. We can't go to the bathroom in my classroom every day. Yep,
I put PA instead of AP.
that's fine.
Oh,
Because of this lines. Yes.
how to know with it, this one, because it seems like you would.
I would highlight it.
You have to use one of the things we learned, like alternate.
Yeah, because angle 5 is that one,
That doesn't ever.
and then angle 3 would be this one. So if I drew that with the remaining lines that were parallel, I actually drew a triangle, right?
Yeah.
Angle 5. Like I said, the easiest way is in your mind, draw your triangle. So in fact, how about we just make sure we have those written down, and then go over them on your leisure. We're just kind of running out of time. I do want to talk about what Grace brought up. How is number 7? How do I do this, and how do I make this efficient on a test? I have colored pencils, right? So you could color stuff in, or you can just do what I'm doing in your mind. Number 7 says angle 5 and angle 3. So if I highlight angle 5, I'd color this whole thing in. Shh. And then I'd color in angle 3. What lines are parallel there? I did a triangle. So then you immediately know it's none. The next one would be measure of angle 5. So I'd highlight measure of angle 5. And then I would do measure of angle 4, which would be this one. Do you see the lines that were formed? And I would use alternate interior angles to show that those two lines are parallel. All right, make sure you have all these down. You can ask questions on it tomorrow. I do want to start the next one really quick. So it says find the values of x and y that make AC parallel to DF. So we're just going to start with that one. So I'm looking at what makes AC parallel to DF. So I'm going to look at alternate interior angles. All right, so I'm going to set up an equation that makes this CBF congruent to EFB. So all I have to do is say 3x plus 20 equals x plus 50, and you just need to solve it. All right, for your homework, I want you to finish this one as well. There's no solution, but we'll just talk about it tomorrow. But that's all you need to do. Look for what needs to be congruent. What was that? Monday, yeah. And in fact, we have an additional assignment on Monday. Also, look at your lesson really quick. I actually put your homework into, oh, I don't have it up here. I've actually put it in your lesson. That is your homework. Yes?
You missed number 29.
That's okay.
No, number 29.
No, number 29. We're okay. So, this is just something I'm going to try. If you like it, I'll keep doing it. But if you just like working towards what?